Hi, good morning, students. Today we are going to discuss about our fourth chapter, the continuation of the last video, Algorithmic Strategies. How do we find the efficiency of an algorithm? There are two factors which determines the efficiency of an algorithm. They are time factor and space factor. What is time factor and what is space factor? Time factor is measured by counting the number of key operations like comparisons in the sorting algorithm. Space factor is measured by the maximum memory space required by the algorithm. So these are the two main factors which influence the efficiency of an algorithm. Why these two factors influence the space, complexity, and time of an algorithm is we know that when we create a program, it is necessary that the operations should be performed very fast. So, the number of key operations in an algorithm determines how much time it takes. So time factor is one of the factor that determines the efficiency of an algorithm. Second one is space factor. We all know that memory space is very essential. We cannot use lot of space for a single program or a single algorithm. So the maximum space required by the algorithm is also a very important factor in finding the efficiency of an algorithm. So these are the two important factors that determines the efficiency of an algorithm: time factor and space factor. The complexity of an algorithm. Time complexity. The time taken by an algorithm is given by the number of steps taken by the algorithm to complete the process. Time complexity is nothing but how much time does an algorithm take to complete the process, the number of steps taken by the algorithm to complete the process. Space complexity. Space complexity of an algorithm is the amount of memory required to run its completion. How much time or how much memory is required to complete the process to get the final result, and how much memory is needed to store it. That is what the space complexity. The space required by an algorithm is equal to the sum of fixed and variable part. So how do we find the space required for an algorithm? It is equal to the fixed and variable part. So let us see what is fixed and what is variable part. A fixed part is defined as the total space required to store certain data and variables for an algorithm. So the space needed to store data and variable for an algorithm is known as the fixed part. What is a variable part then? It is defined as the total space required by the variables which is in the loop. So the total number of space required by the variable is known as the variable part, and the space required to store data and variable for an algorithm is called fixed part. Time space-time trade-off. A space-time or a time-memory trade-off is a way of solving in less time by using more storage space. So it is another technique of improving the time of an algorithm by using more storage space. But the time requirement is very less. It is known as space-time trade-off. So when the amount of storage space is more and the time taken is less, it is known as space-time trade-off. Asymptotic notations. What is asymptotic notation? Asymptotic notations are languages that uses meaningful statements about time and space complexity. So in order to refer about the time and space complexity, we use a particular language. It is known as asymptotic notation. There are three asymptotic notations. First one is big O. Big O is used to describe the worst case of an algorithm. We'll discuss about the worst case in the next slide. Second one is big omega. Big omega is the reverse of big O. Big omega is used to describe the lower bound or the best case. Third one is big theta. When an algorithm has a complexity with the lower bound equal to upper bound, an algorithm has a complexity O, n log n and omega n log n, its actual complexity is theta n log n. So this is used for finding the complexity of an algorithm. Theta n log n is used for finding the complexity of an algorithm. So now let us see what is a worst case and what is best case. Best case. In the best case analysis, we calculate lower bound on running time of an algorithm. We must know that the case's minimum number of operations to be executed. In the linear search problem, the best case occurs when X is present at the first location. The number of operations in the best case is constant. So, best case analysis or best case is known as when we run an algorithm, the required result is found very soon. The required answer or with the required element or value is found with minimum search. By one or two searches, you will be getting the result or the value. Such algorithm is known as best case algorithm. What is worst case? In the worst case analysis, we calculate upper bound on running time of an algorithm. We must know that the case's minimum number of operations to be executed. For linear search, the worst case happens when the element to be searched is not present in the array. When X is not present, the search function compares it with all the elements of the array one by one. Therefore, the worst case time complexity of linear search would be theta n. So, in simple words, we can say that in worst case, when we make a search, the element is not found or the value is not found. In such case, it is known as worst case. Best case is that within one or two search, the value is found. In worst case, even if we go through all the elements, the value is not found. The techniques used in algorithm for searching are: first one is linear search. These are the techniques used for getting the values from an algorithm. First one is linear search, second one binary search, third one bubble sort, fourth one selection sort, fifth one insertion sort. So these are the 5 techniques used in algorithm for searching the values. The linear search technique in algorithm. This linear search is otherwise known as sequential search. It is a sequential method for finding a particular value in an unordered list. We know that when so many values are given without a particular order, if you want to find a value, it is we have to go one value after the other, one after the other. First, we have to search that the first value, whether the value is equal to this. Then we have to go to the second value, whether it matches. Then we have to go to the third, and then fourth, then fifth. It goes like that. So it is known as a sequential method to find the particular value. This method checks the search element with each element in sequence until the desired element is found. So first it searches in the first element. If it matches, it takes that. If not, it goes on checking the element in the array. So if there are 5 elements, all the 5 elements will be checked until the desired element is found. Pseudocode. In the array, using for loop, in every iteration, compare the search value with the current value of the list. If the value matches, display the current index and the value of the array. If the value does not match, move on to the next array element. If no match is found, display not found. Example, input values are 13, 31, 28, 11 and 2. The target is 28 and output is 2. So this is a simple pseudocode. Pseudocode, we know that the process how we get the value or what is to be done. So in an array where we use for loop, we are going to find a particular value from a list. So let us see how this pseudocode happens. So here are the values which are given as 13, 31, 28, 11 and 2. So here our target is 28 and the output is 2. So when we give the target 28, how do we get the output as 2? Is the index value or the positional value of each element. The positional value or index value of each element is taken. So now the values 13, 31, 28, 11 and 2 are having the index values 0, 1, 2, 3 and 4. So the value 13 is having the index value or positional value as 0. 31 is having the index value as 1. 28 is having the index value as 2. And 11 is having the index value 3. 2 is having the index value 4. So since our target is 28, the value 28 falls in the index value or the positional value 2. So that is why we get the value 28. So the value 28 matches, it displays the current index value as 2. That is why the target, when we give us 28, we get the output as 2. Okay, thank you students, and the remaining topic will be dealt in the next class. Stay home, stay safe. Thank you.